Right, shall we continue on with our corrections, and we'll continue with this review 5. Number 11, write as decimal. Write the decimal. Okay, let me take a look here. Write the decimal. Let's take a look. 7 plus 0.6 is 7 plus 0.6 is 7.6 plus 0.02, total 7.62. This is 10.44, right? For corrections, I'm doing very fast. Now this, what you do is we convert this into decimal and this into the decimal. All right, so it's 5 point something. This is 0.1, right? Therefore 5.1, and this is 0.08, 5.18. Next, D, 9 plus 3 over 10 plus 7 over 100, the same thing. Look over here, convert to decimal, right? This is 0.3, and this one is 0.07. Add up, total is 9.37. Right, copy down for corrections. Let us continue with number 12. Fill in the blanks. In 14.66, the digit 8, here is 10th, here's 100th. Okay, it's in the what place? 100th place. HUNDREDTHS, 100th place. The value is 0.08. Number 13, how many cents? This is straight away you can see. If you're used to it, 75 cents, then just go right. This over here, you put 25 cents, just go through 1,225 cents, and this is, when you can see over here, 805 cents. Right, next for number 14, write each amount of money in decimal form. 65 cents is $0.65. This $10 itself, so you leave $10. After that, these are cents, dot 90 cents, $2.05, 2.05. Right, that's decimal. Right, if you see here carefully, 9 over 1,000, right backward this way. Okay, now the decimal point should be here, up this way. All right, this 0, leave it up. Okay, they put this. Okay, so it's 0.009. This is 0.063. Now remember, when it's 1,000, you make sure there are 3 decimal places, right? 1,000, 3 decimal places, and for hundreds, 2 decimal places, and for 10 is 1 decimal place. All right, and this is this over here is good. It's wise for us to convert into improper fraction. So what we can have here is 2 times 1,000 is 2,000. 2,000 plus 137 is 2,137. All right, if it's divide, it is same, divide by 1,000. Now same thing, take a look here, the decimal point, move up this way, put the decimal point. Okay, your answer is 2.137. Now let's carry with question 16. 0.005, this is 10, this is hundreds, this is thousands. 5,000, 5 over 1,000. So you just put 5 into. Right, over here is if you see carefully, 8, you just put it here, and the rest follow 3, 2, no 0 point anything, because 3 decimal places means something to do with thousands. And this is 16, is this 16,000? All right, you have to increase it into 3 decimal places, put a 0 there. Right, 3 decimal places is 1,000, so this is 160. Next, for number 17, fill in the blanks. 0.023, 0 tens, correct, and 200s over here, and 3,000s. This over here, 407, 4 tens, 0 hundred, and 7,000. And this over here is 3 tens and 500s and nothing with thousand. It means this way, this is 0 over here, no thousands. Right, we go to number 18. What they ask us to do is like this. 1.234 can be written as 1 plus, after the dot is the first one is the 10, 100th, and the other one, this one is 4 over 1000. So if you convert them, change the decimal, it will be like this. Okay, it will be like this. Now let's go into fractions first. This is the fraction part. Below can see this is the decimal part. Now the first one is 3 over 10. Second is 2 over 100. The third is 5 over 1000. 3, 4. Now how about this? 6 is the whole number. There is no 10, so I leave it over here, leave it empty. The next is 6 over 100, because 6 is at the 100th place. And the last one will be 7 over 1000. Next, 8104. There's something in 1, so it's 0.1. Nothing in the hundreds, but something in the 1000, the thousands. 0, 0, 4. 10.792. Okay, the 7 is 0.7. The 9 is 0.09. And the last one is 0.002. Number 19, fill in the blanks. In 12.069, the digit 9 is the thousand place, T. You see, I'm running out of batteries. Thousand place. And the value is 0.009. Right, let us continue with this. Fill in the blanks. Now this we have to be extra careful because sometimes we may just misread and get certain things wrong. Right, this is just the same as what you have done, but the numbers are different. The way the number presented now is in decimals. Now for A, take a look. Let me get you something in the box. Now take a look over here. 0.1 is more than something. 0.1 more than something. This 0.1 is a difference. Something is more than something. So one of them, a number, is more than the other number. Okay? Something is more than something. Okay? More than a smaller number. So 1.1 is a small number. 0.1 is the difference. Right, let's take a look. Let me dig into a freehand. Okay, so this is a difference. You put 0.1. 0.1. And more than a small number. This is a small number. This must be the bigger number. Okay, and this is the difference, T. Alright, so difference is 0.1. More than smaller number, 1.1. Alright, and you get this number. So how do you get this number? The small number plus the difference. Okay, I'll just get the calculator out for you to see. Let me get a calculator. Just hang on first. Okay, I'll get is 1.1 plus 0.1, total is 1.2. The big number is 1.2, so this big number here is 1.2. Right, next let me erase this first. Get the calculator down. 0.2 less than 2. Less than 2 means 2 is the bigger number. Okay, less than 2.0. So 0.2 less than 2 is 2.0 minus 0.2 gives you 1.8. This is 1.8 over here. This is 1.8. Right, let me just draw the answer. 1.8. The top part is 1.2. 0.01 less than 0.01 less than 0.1 is. Now less than a big number, this is a big number, this is the difference. Alright, and this must be a smaller number. Now let's go on to the next one before I give you the answer. You have to check yourself for yourself with. Now you have this more than over here. Sorry about that. Just give me a second. Let me stop the right, let me start over again. 0.1 more than 1.1. This is a small number. This is a difference. The number just behind the keywords, okay? And this must be a big number. Now how do you get this big number? The big number means the small number plus this. So this big number is always the small number S plus D, the difference. S plus the difference give you a big number. So that should be your answer. Calculate on your own. Let's confirm with this one. Less than, something less than a big number, right? And this must be the small number. Alright, 0.2 is the difference. So small number is always the big number takes away the difference. Can you see? Now less than a big number. Again, this is the difference, right? And this must be the small number. How do you calculate small number? Small number is the big number takes away the difference. It's similar to the one, all right, above. Now more than a small number, this must be the big number. So this is the difference, D. So big number is actually small number plus difference. You can see this is similar to the one on top. The concept is always the same. More than a small number, this one must be the big number. This is the difference again. So big number is small number add on to, yes, the difference. How about this? Less than big number. This one must be the small number. Right? How to get the small number? Small number is the difference. Is the big number minus the difference. Now work this out on your own. Okay, let's go to number 21. Mark this decimal on the number line. Write the decimal below each cross, as right across below. 0.16. Okay, this one I believe is it leaps by 0.04 and then 0.04, and this one must be, let me take this one must be 8, right? The next one must be 0.12. This one is 0.14, and this must be 0.16. 0.16 is here. Is it? No. Just hang on first, huh? Let me do that again. Leap by 4, this should be 12, 1, 6, correct? 20, 24. Okay, good. Let's confirm. This is 8, 12, 1, 6, and this is 20, this is 24. This is this, and this is this. Right? Now take a look at the number 22, right? Greater or smaller. Now 4.1, there's the ones, there's the figure 4 in the ones place. Definitely this is greater than 0.41. Okay. Now 0 point something, and this is 0 point something. Okay. This is you see carefully, this over here looks like 703, and this one you compare, this is not 73, right? This 730, right? It looks like 730, and this is 703. So definitely this is greater than that, right? How about this? 126 is what? 26. Now look at this. Here looks like a 260, but this is only 126. Therefore, the first number is smaller than the number. Let's go on to number 23. Shift it up. Alright. Now circle the greatest decimal number and underline the smallest number. For this, I would really like you to arrange them using the decimal point. For example, for the first one, A, you put the decimal point here, and decimal point here. For 3 of them, compare, right? 3.04, 3.04. Next is 3.4, 3.4. Right, to make it easier to see, I put a 0 here. And the next one is 0, 3, 0, and 4, the last one. Okay, to make it easier to see, put a 0, 0. Alright, it's perfectly fine. You look at this way. Now, at a glance without the dots, the decimal point, you see this is like 3040. This is 3400, and this is only 340. So from here you can actually see the largest number is 3.4. It looks like 3004. Second one is the top, and third one is 304. So the smallest one we underline 304. This one, this is the smallest, and the largest is this. Right? You have to arrange like that. Right, just now what we have was on top here, 3.4, and this is the smallest, and this is the largest. Let's take a look at this. 0.6 looks like 600. 0.61, 601, this is larger than that, and this is 65. So this is the largest, and this is smallest. Now this look as if it's 600, right? 600. Next, C, 0.025 looks like a 25. This looks like a 250, and this is 205. Okay, this is middle, this is the largest, and this is the smallest. Now let's take a look at number 24. Given a number that is greater than 0.09 but smaller than 0.1. Now look very carefully. Okay, this one I can just put here 1, 2. It looks like 100. If I balance up the decimal point, it looks like a 90. Right? 90 compared to 100. In between, all the numbers between 90 to 100 could be 91, 92, 93, all the way to 99. Now, you see very carefully, 3 decimal places. Okay, so you do the same. This is you put 3 decimal places, dot 091, and here dot 099. Okay, 3 decimal places each. So your answer can be from 0.091 all the way to 0.099. Any of the answers here. Okay, take a look at this. Now this is very important to see whether you understand. For whole number do not have any decimal point. 8, look at this. 8, this is the number in question. Whole number is 8. Okay, for this whole number it is 6. Can you see 6? The number in question is 0, right? But whether I'm going to change it to 0 or to 1 depends on this number 6. Now this number 6 is nearer to 1, so over here the whole number is 1. 0.607 is nearer to 1 whole, and on top 8.052 is nearer to 8 but not nearer to 9. Okay, for the tens over here, 8.052, 052. Now the number to be changed is this one. Okay, it could be 8 point something. Now 0 to change, we look at the number beside, it is 5. 5 is nearer to the other number. 05 is nearer to 10 compared to 0. So this is 8.1. And the bottom here is what do we have here? The 10th here, the 10th. This is left with still 10, 0.6. It doesn't change to 7. Why? Because the number next to it is 60, exactly 0.6. Now let's round to the nearest 100. This one is 8.0. Nearest 100, the number to be changed is 5. Should it be changed to 6 or remain as 5? So you will see the next number over here, number 2. 52 is nearer to 50 than 60, so we don't change this to 6. So 52 is nearer to 50. It ends up with this 5. Now when you have the hundreds here, you make sure there are 2 decimal points only. And for this 0.6. Okay, now take a look at this. 7 is nearer to 10. Right, 7 is nearer to converting this whole thing to 10. Alright, 7 is not nearer to the other side, 0. So this one is, leave it as 1, 0.61. Alright, round off 7.99 to 1 decimal place. Now 1 decimal place, it means here. Okay, I end up the number with here. So this is 9, right? Should I round down to 90, or for this should I round to 100? Now 99, can you see here very clearly, 99 is nearer to 100. So it got to be you plus 1, this one becomes 0, and this is 8. All right, 1 decimal place, so it's got to be like this. 8.0. 8.0. Now to the nearest 100, let me write down the whole number again. 7.997. Okay, to the nearest 100, it means the number to be changed is this. 9 remains. 9 remains. Alright, but if it's being added to 1, alright, if it's being added to 1, then I could carry this 1 forward to the, regroup it to the 1's column. Now check this. This is to be changed. 97. Look at it. 97. 97 is nearer to the next 10th. It means 97 is 100, next to 100. So you just add 1. This one add 1. This one will become add 1. This one becomes 0. And you bring it 1 here. This will become 0 and plus 1 here. Right? So your answer is, okay, 8.0. 8.00. Why is it 8.00? All right, let me just rewrite again. The answer is 8.0 and 0. Why? Because your answer got to be in the hundreds. Nearest hundreds, it has got to be 2 decimal places. Next, 27 Yenny is 1.69 meters tall. Round off Yenny's height to the nearest meter. Nearest meter is here. Okay, the question is here. Change this one. Should, look at here, should 16 be round off to 20 or 16 round to 10? So it's round off to 20, right? So it becomes 2.0 and so on. But if you put nearest to meter, so leave that 0.0 alone, just put 2 meters will do, because we are rounding off to the nearest whole number. Now the 10 of the meter, it means the next one is a 6 in questions. Now to see whether we change this 6, we look at the next number, 69. Is 69 nearer to 70 or 60? So it's nearer to 70, right? So we round up. So 1.7. Okay. Now a 10th of a meter means I got to leave only 1 decimal place. And remember, please put your unit of measurement. Right. We'll continue to the next one here. I'm going to shift it up. Number 28, Yeti's height is 1.5 meters. When rounded off to the nearest 10th of meter, find up to 2 decimal places. Okay, her greatest possible height. It means what was her greatest possible height that's been rounded down, okay, to 1.5, or the other one is what was the shortest possible height that has been rounded up to 1.5 meters. Right, this one is 1.54. Right, that's the greatest. Okay, I'll put a meter there. The greatest possible height is 1.54 rounded to 1.5. Why is it? Right, if it's 1.55, it would have been rounded to the next number. It would have been rounded to 1.6. Therefore, this is the greatest number, right, to be rounded down to 1.5, not further than that. The smallest number will be 1.45 meters, right? 1.45 meters. If this is 1.44, then it will be rounded down to 1.40. Right, but since it's 1.45, 45 is nearer to 50, so it's rounded down to here, the 50 here, 1.5. Next, convert each decimal to a fraction. Express the answer in the simplest form. This is simple. This is the 10th, so it's 6 over 10. Now remember, 6 over 10 is just a fraction. Simplest form, continue, divide by 2 again is 3, right, over, this is 5. Next, 0.55, 5 is 5 divided by, okay, 10, 100, so you put a 100, right? Divide this by 5 is 11. Cannot, yeah, can. Divide this by 5 is 11. Divide 100 by 5 is 20. Can we divide this further down? There's no common factors, huh? So 0.55 to change to simplest form in fraction is 11 over 20. Alright, converting each fraction into decimal, 1 over 5. Now what is interesting about this is that the best way to do is change the denominator, each of these denominators, into tenth, 100 or 1000. It will be much easier. Now let me click to draw. 5 over here, you change to 10, you times 2, right? So top times 2, bottom times 2. 1 times 2 is 2. 5 times 2 is 10. Alright, to convert to decimal, look at this point here, move up, put a decimal point, write a 0. Okay, I'll cancel the 10 away just not to confuse you. 1 over 5 is 0.2. Alright, because I've just changed it to 2 over 10, then I get a decimal place up. Now let's take a look at B. 9 over 20. Now convert this into 100. Convert this 100 times, what do we do? Times 5. So this is 100. A nice one, 100. Okay, and this is, if you times 5 is 900. 9 times 5 is 45. 45. Same thing to the decimal conversion. From here, leave out a dot, put a 0, and of course I'll erase this off. So 9 over 20 is 0.45, right? You can check that by using a calculator. 9 divided by 20, you should get 0.45. Okay, now this difference is 5 over 2 in proper fraction. Okay, so you expect the top number here to be bigger than the number at the bottom. Now 2, I'll change this nearest to 10. Right, this is to 10, so 2 times 5 is 10. Okay, 2 times 5 is 10, and 5 times 5 is 25. 25. Alright, now how do you put a decimal? From here, remember, after 1, leave it up, put a dot there. Okay, so 10. Now remember, see this carefully. 5 divided by 2 means like $5 divided by 2, okay, is $2.50. Can you see? Next, 3/4. Now 3/4, every time I look at 3/4, straight away I know it's 0.75. It's very easy. Alright, you have to get used to it. If it's half, it's always 0.5. If it's 1/4, it's always 0.25. Now for 3/4, or just to prove to you, 4, I can times something and make it into 100. So 4 times what? Yes, 4 times 25 gives you 100. 4 times 25 gives you 100. Top times 25. 3 times 25 is 75. Okay, now the same thing applies. Put the decimal dot here above, right? Right, the 0.75. Okay, so 3 divided by 4, or 3/4, is 0.75. Now let's continue with the this few here. Fill in the blanks. 22 tenths is how many ones? Wow, 22 tenths is how many ones, how many tenths? Okay, do not be afraid. Take a look at this, right? Change it. 22 tenths, you just put 22. Alright, 22 divide by 10 first. Okay, 22 divided by 10. Now convert this whole thing into decimal so that you can do this part easier. Right, decimal, put this dot over here. So it's actually 2.2, huh? 2.2. Now 22 tenths is 2.2 in decimal. Now over here is the ones. Therefore you have this here. 2 ones is this, right on top. And 0.2, this part is 2 over 10 is 2 tenths, right? 2 tenths. Right, for here, 1/1600, 1/10, this is the 1/10. The 6 is under the 100, so you put here 6. Now similarly for this, you want to use the top method. Alright, it's very possible. I just show you one more time. 1600, let me write the example at this corner. So we put 616, okay, over 100. 16 over 100. Now the decimal point, look up. Okay, here, put the decimal point. It's actually 0. I just erase this off. 0.16. So 0.16, you see that this one is the 110. That's why you have it here, 110. And this is the 6 over 100. So you have 6, right? 6 over 100. Right, for this, I'll just speed it up. 3 ones, 2 tens is this. 2. 0.45 is 410. This is 4 and 5 hundredths. Alright. Sometimes at a glance you may be able to just fill the numbers in, but be very careful. You may be told to fill up this as thousands. Alright, it's different. Right, let's continue with this. Number 32, add. Probably I'll check you with the answer. I'll just use the calculator, check your answer, but you have to work it out yourself at home without using the calculator. Right, for A over here, right, A is 6.74 plus 2.17, so it's 6.74 plus 2.17, right? Your answer should be 8.88. For B will be 3.28 plus 0.91, so 0.91. Your answer should be 4.19. For C will be 5.76 plus 4.26. okay, your answer should be 10.02. now number 33, subtract. Now this time subtract, do it carefully. 7.05 takes away 1.33, right? Your answer should be 5.72. next, B for 33B will be 8.72. 8.72 takes away 3.43. Okay, 5.29. let me shift the calculator higher a bit just to do this. For C, the last one for here, right, 6.36 takes away 6.36 takes away 5.79. okay, your answer should be 0.57. we scroll down to 34. let me get the calculator up. Now same here, for this 3 of them. Alright, 2.5 times 5. when I look at this, it looks like 2.5, the answer straight away. So let me get it out for you. 2.5 times 5 should be 2.5. yes, 2.5. the answer for this A is 2.5. next, 5.07 times, is it times? Okay, where's my times? Yes, over here, times 7, right? Is 35.49. 35.49. and the last one, 8.46 times 6. 8.46. your last answer should be 50.76. right? Now I'm going to shift out the answers for close this thing first. Shift out the answers for you to check. For number 35, number 35, A, okay, B, C, D. Now this is your answer. You may pause the screen to copy down for your corrections. Make sure every correction you must show your workings, right? If you're finished with this, I'm going to scroll up now to number 36. Now for this is special. It says answer your question to one decimal place. Now let's take a look here while I'm screwing this thing up. Okay, now 0.77 divided by 5 after all the calculations over here, right? The answer is 0.15. So to round it off to one decimal place, it means it could be something like this, right? One decimal place here. 15 is nearer to 20. So I round up to 0.2. 0.15 round up to 0.12. That should be your answer, getting this way. So this one, 157, round up 57 is nearer to 60. So this is 60, right? 1.60, 60. Over here, 0.37 is nearer to 40, right? 0.4. And 83 here, 83 is not nearer to 90, but 83 is nearer to 80. Therefore, it's being rounded down to 0.8. Let us shift up a little. Now this, I will not use the calculator or so. Check your answer. 73, 55, 4 and 0.05. Work it out. Work it out again. When you do corrections, do not just leave the answer there. Work out the working over here yourself and make sure you get the correct answer. Now shift the page up. One kilogram of fish costs $9. Susan buys 0.45 kilogram of fish. How much change will she get if she pays the cashier $10? Alright, let me just double check here. Okay, 1 kilogram of fish costs $9. Susan buys 0.45 kilogram of fish. Okay, look very carefully. Now she bought less than 1 kilogram of fish. Okay, in fact 0.45 out of 1. Now to find out how much 0.45 costs, okay, you take this, right? You take 0.45 times 9, right? 0.45 times 9. Okay, let me get the calculator out for you. Right, of this 0.45 times 9 is equal to, just hang on for a second one more time, 0.45 times 9 is $4.05. $4.05. Okay, so $4.05 is the amount he's going to pay for 0.45 kilogram of fish. Right, now when she takes out $10 and pays $4.05, what is the amount of it means what's the change? The change is take $10 takes away $4.05, right? So you should take $10, right, .00 takes away $4.05, right? Your answer for this change should be 595. 595. Right, for the next few questions, question 39, bricklayer had to build some wall. After building the wall for 3 days, he still had another 5.8 meters of the wall to complete. Right, he built the same length of wall each day. How many meters did he do to complete one day? Take your time to understand this question. I'll just flash the answer for you. Okay, copy the answer down and make sure you understand. Right, this is the balance over here. Then later takes away the remaining what he has actually done was this: for 3 days 25.5, then if you take 25.5 divided by 3 each day, right, he completed 8.5 meters. Let's go to question 40. Rina saved $4.50 each week. Her sister saved $2 more each week. When her sister has saved $14 more than Rina, how much has Rina saved? Right, take a look. It means you don't really bother about how much more or how much they save each, but watch out for the keyword how much more. It is $2 more. Okay, so for $14, having $14 more, okay, how many days actually has she saved more than her sister? So if you take 14 divided by 2, it's actually 7 days. Okay, 7 days. So we determine the days. Okay, they have been saving for 7 days. Alright, that's why you have $14 more. Then later on they ask how much Rina saved. Take Rina's money. Okay, take Rina's money, 450 times the 7 days, so you can get the amount of money Rina saved. Next, for this I'm going to go through another video. I will record it later. I'll just show the flashy answer straight away.